Good morning, students. This is M. Suresh, lecturer in Computer Engineering, Government Polytechnic Masabtank. Today I am starting chapter 3 in C++ subject, that is your OOPS through C++ for the 4th semester students, and the subject code is 18CM402C. So let us see. This chapter mainly deals with C++ IO operations. Okay. So in case of sorry, C++ IO operators and their meaning. What are the different C++ IO operators are there, and what is the meaning of them? And the second one is what is the basics of formatted IO. Okay. So let us consider the first topic, C++ IO operators with their meaning. Okay, we have already seen this one. Okay, in the previous classes, C in, C out. Okay, those are the main operators which are used to do input and output operations, and these input and output operations will be performed by using iostream.h. Okay, C++ has a rich set of functions for performing input and output operations. It has many functions which are used for performing these input output operations. In case of C language, stdio.h is there, which contains printf and scanf functions which are used to perform input output operations. In case of C++ also we have different functions like get line, put line, write. Okay, we have different functions, read, write. Okay, the syntax of using this function is totally consistent irrespective of the device with which IO operations are performed. Okay, C++ new features for handling IO operations are called streams. Okay, in case of C++, this input output operations can be done by using a special concept called stream. That's why we are using iostream.h, that is input output stream.h header file. In case of C++, IO are based on streams. Here stream is nothing but a sequence of bytes flowing in and out of the programs, just like water and oil flowing through a pipe. So we can take this stream is nothing but a stream of, okay, a stream of bytes. Okay, a stream of bytes which are flowing like this. Okay, so that is your stream, which are sequence of bytes flowing in and out of the programs. Okay, if you have a program and here we have input device keyboard, we have input device like keyboard, or we have output device monitor. So whenever the program is written the cin statement, it has to take the data from the keyboard. So keyboard will give the data and it will be flow through this buffer and it will be taken into the cin object, which variable you want to take or something. And whenever you are using cout, then it will display the output on the monitor. Before displaying on the monitor, it will flow, this sequence of bytes will be flow into this buffer. So this is called a stream. Okay, in case of C++, this input output can be based on these streams, which is nothing but a sequence of bytes. Okay, so in input operations, data bytes flow from an input source, so from keyboard to your program. And whenever we are having this output operation from this program to monitor, it will flow through this buffer. Okay, so that is about this concept, simple buffer. It is like a simple it's a buffer so that this data can move easily, flow a sequence of bytes through that buffer. Okay, that is called your stream. In output operation, data bytes flow from the program to an output device, that may be console, that may be file. I can post the data from my program into a file or into a network or any other program. Okay, streams acts as an intermediary between these programs and the actual IO devices. Okay, streams acts as a intermediary. So this is acting as a interface through which from my program I can a group of data can be flow and it will be shown on the monitor, or from the keyboard I can take the data and that will be flow through the stream and it will be taken into the program. Okay, this is this one. Okay, in such a way that frees the programmers from handling the actual devices, so that it is achieve a device independence. There is no dependency on the devices, just It's a flow of bytes which are flowing from or flowing into this one. Okay, flowing from this one, and those will be taken into the program, or flowing out and it will be shown on the monitor. That is about C++ IO operations or streams. Streams are abstractions that refer to data flow. Streams are classified into two types. One is the input stream and the output stream. Input stream is nothing but taking data. Output stream is nothing but displaying onto the monitor. So if you have a C++ program that is opened in Turbo C, I am writing this program in the Turbo C. Internal data formats, text, character, okay, int, float, double, like this we have. So whenever we are having this cin statements, cin is input statements, okay, cin. So whenever we are having this cin statement, whenever we are having this cin statement or cout statement, whenever we are having this cin or cout statement, okay, so whenever we are having this cin statement, then this data will flow from this input keyword. Whatever the data that we are having, we are writing on the input source. Okay, we are taking this one. So this is your program, C++ program, and in this C++ program, whenever you are using this cin statement, okay, cin, and this operator is called extraction operator, because we are extracting the data from the keyboard. Okay, whenever you are using this one cin, then from this keyboard, whatever the data that is entered, that will be flow from this input stream, and this will be taken into this C++ program. So this is about your cin statement. So whenever you are using this output stream, when you are using this cout statement, okay, if you are using this cout statement in your program, then whatever the data that you are writing, that will be flow from this output stream, and that will be shown onto the monitor, or that may be data will be inserted into the file, or it may be into the network or another program. And whenever you are using this input stream cin statement, then the data can be taken from the keyboard, or the data can be I can take from the file, or from a network or program. Okay, and this is about internal data formats and external data formats. Okay, next one we will see in detail. So what are the different streams? So the output stream allows us to perform write operations on the output devices. Okay, always output stream is nothing but it is doing write operations. Okay, so generally we will write the data onto the monitor. Okay, general case we will write the data onto the monitor. Output on the standard stream is performed using the cout object. So the syntax for the standard output stream operation. So generally standard output device is monitor. So if I want to do operations on the standard output devices, then I will use this cout object. So output stream, what is the main purpose of output stream? It will be allow us to do write operations on the output devices. So the output on the standard stream is performed using the cout object. So the syntax for this standard output stream is cout, this one, cout variable. Okay, so this one, and input stream. So input stream, what is this one? Which is used to take the data, read operation. Okay, always output stream is used to perform write operations. Input stream is used to perform this read operations. Input from the standard stream is performed by using this cin object. So whenever a standard input device is nothing but keyboard, so whenever we want to take the data from the keyboard, then that is possible through this cin object, because cin is the standard input object, standard stream input stream object. So cin object, the syntax for the standard input stream is nothing but cin variable. So output so output stream is nothing but cout variable, and input stream is nothing but cin variable. Performing these input-output operations through cout and cin are similar to printf and scanf in case of C language, but only thing is there is no concept of this ampersand. Okay, that is address of operator. No need to use that. Format specifiers, no need to use. The difference between streams and these IO functions is streams do not require explicit data type specification. In case of these streams, in case of these input-output functions, okay, that is printf and scanf, I have to use a specify the data type. If it is sorry, it is of integer type means %d I have to use. If it is of character type, then %c. If it is of float type, then %f. Like that I have to use. But in case of these streams, okay, using streams, that is input stream and output stream, there is no need to specify this explicit data type. And the next one is no need to specify address of operator. That is, whenever you are using this scanf statement, in case of C language, whenever you are using this scanf statement, I have to specify %d, comma ampersand, if maybe variable is a, then I have to specify like this. So %d is for integer and ampersand is nothing but address I am taking. But in case of C++ language, if I want to take that value, just see in A, there is no concept of this which data type I no need to mention by using format specifier, and no need to mention this address operator. Okay, this is the differences. And what are the header files available in C++ for doing this input output operations are, we have this iostream.h. okay, so the first one is io, this is most commonly used, io stream.h. This is a header file which is used to do both standard input output stream operations. The header file contain definitions for objects like cin, cout and cin. Sorry. Next, IO manipulation. IO manipulation stands for input output manipulators. Yeah, the first one is iostream.h, which is used to do both standard input operations and output operations. This contains we have different streams in iostream.h. okay, that is, whenever you want to use this one, hash include iostream.h. this is the header file. This header file contains all the classes, that is iOS class is there, and iStream class, next OStream class and iOStream class, and for all these classes we have different objects, like cin is an object of this iStream class, cin is an object of iStream class, and OStream class we have cout is an object of OStream class. Okay, all this we discuss. So the first one is iostream.h header file, and the second one is iomanipulator.h, which is used to, the name itself indicates that IO manipulation. If I want to do input output manipulations, then I will go for this IO manip.h. The methods, if I want to display the output in specified format, or if I want to do input operation in specified format, then this type of manipulations I can do by using iomanipulator.h. The methods declared in this file are used for manipulating streams. This file contains definitions of set w, set precision. We will discuss. Okay, we have different functions that are there in this iomanipulator.h header file, which are used to manipulate the data. And the next one is fstream.h, which is fstream, that indicates that itself indicates that files. Okay, so by using this fstream.h I can do file operations. Okay, this header file is used to handle the data being read from the file as input or data being written into the file as output. Okay, that is fstream.h. And next, C++ IO operators. C++ contains several predefined streams that are open automatically when the execution of a program starts. Okay, so C++ contains several predefined streams that are open automatically when the execution of a program starts. The four standard streams are cin, cout, cerr and clog. Okay, these four standard streams are there, that is cin, cout, cerr and clog. Okay, these are the four predefined these are the four standard streams which are used to perform this standard input output operations. Okay, cin is nothing but standard input which is used to do input operations, the more which is a standard input device. Okay, which is used to do input operations through the standard input device, that is keyboard. And cout is nothing but which is used to do standard output operation by using monitor. Cerr, that is standard error output, usually screen only. Cla, this is buffered output of standard error. These are the four operators that are there, IO operators. So standard input stream, usually the input device is the keyboard. Cin is the instance of the, so usually the default input device is keyboard. Okay, default input device is keyboard. So cin is an instance of this class iStream. Okay, we have different streams, I already said. Okay, so this we have a class iStream. Okay, in case of IOStream.h, we have a class called iStream. So for this iStream class, we have different member variables and member variables. So one of the object for this iStream class, that is iStream. How will you create the object for this iStream class? iStream cin, that's it, right? So cin is an object of iStream class. Okay, so the class iStream and is used to read input from the standard input device, which is usually keyboard. So if you take the standard input streams, very sorry, yeah. So standard input stream, usually the input is the input device is the keyboard. So cin is an instance of this class iStream and is used to read input from the standard input device, that is keyboard. Okay, so if you have a class iStream inside this header file, then for this iStream class we have a object that is cin. So by using this cin, I can have different methods like get method and read method, and these are the member functions of iStream class. Next, void maybe or any other data type. Okay, so these are the different member functions are there. So if I want to access these member functions, then cin, and we have operators also, that is if I take void operator, whenever I discuss operator overloading, then you will understand. So there is an operator called this one. This is the operator keyword, and what is the operator that I want to overload, that is your operator overloading. So this is for different for different operators, that's why this is called operator overloading. If I have float, then operator greater than float, like this we have different operators. Okay, so whenever we want to take the data from the keyboard, then cin is an instance is nothing but object. So cin is an object of iStream class and is used to read the input from the standard input device, that is keyboard. Or it will have this extraction operator, this is the extraction operator, which is overloaded along with the object cin for reading inputs. The extraction operator extracts the data from the object cin, which is entered using keyboard. Okay, so if we take this one, hash include IOStream.h, so int age, enter he will enter the age, so that it will take from the keyboard cin age and it will display that age. Okay, so cin is mainly used to take the data from the keyboard. Internally this cin is operator, it is nothing but, so whenever you are writing this cin age, internally what it will call is, so whenever you are writing like this, so internally what it will in cin dot operator, so of integer parameter, which is function is there, that function will be called. Okay, I will show this one. Okay, so if you take this example, write this one, include IOStream.h, hash include conio.h. Okay, so here I am not writing this one into main, so void main I will take int age, cout, enter your age. C in age. Now I am displaying that age. C out slash n just for a new line. So your age is. Here I am using cout also, standard output operator also, but so just I will clear everything, and here get ch function is there, and here clear screen. Okay. I will save this with the temp.cpp io.cpp. So now I will execute by using this one. So whenever F7 is pressed, main section, clear screen will be cleared. Cout, enter your age. So you just see here which function is called IO. It will go to this IO stream .h. I am including TC in the TC folder, include folder. I have this IO stream .h header file. So whenever I am using this IO stream .h header file, so you just see here. Okay. So this is your IO stream.h header file. So this was written by the whenever they created this C++ libraries, they Borland, okay, international, okay. So and after this, these are the hash diff and statements, all these things, okay, type def. So here this class is here. So this is the class, and what is the name of the class? IOS, okay. So this is the class IOS. In that class IOS, we have in the public section all these different states are there, mode is there, okay. So enum type is there, and virtual method is there, okay, all these things. These are class IOS, protected variables, different things. Next, stream buffer. This is also another class, okay. This is stream buffer class, okay. I will show all these classes. This is stream buffer class. All these are there in the iostream.h header file. Within the class, I can have data members and member functions, different member functions. All these are inline functions because I am defining inside the class stream buffer. And we have one more class called iStream class, okay. This is the iStream class. Whenever you are using this syntax, okay, whenever you are using this syntax, that is nothing but inheritance, okay. I will show this one in the next coming classes, okay. But so this is a class, and what is the name of the class? iStream class. And which is here, what is the, here I have to use this access specifier, okay, visibility modes we will call. And what is the super class for this one? IOS is the base class. So iStream is the subclass and IOS is the base class. Why I am using this virtual class? Because that is called multiple inheritance, okay. Multipath inheritance. Wherever you are using this multipath inheritance, then the common base class I have to define as virtual. So that's why it is virtual. So here iStream is the class, okay. Inside this iStream class, we have the destructor, okay. Constructor is there, one constructor is there, destructor is there, and get method is there, okay. This is the get method, and this get method is returning of iStream type only, okay. This is nothing but it returns the object, it returns the object type only, get function, and that to reference, okay. Get read function is there, get line function is there. All these are the functions. These are called member functions. Get functions, get function, that too for each one character, okay. It will take character. Peek function is there, g count, put back, ignore function is there, and all these are called operator overloading. And these operators are, all operators are returning this iStream class, same returning object only, but that to reference, okay. So operator greater than, this operator also we are writing for each separately. This is signed character, unsigned character, signed short, int, long, unsigned short, unsigned int, unsigned long, all these things. So that this is called operator overloading. The same operator I can use for different purposes. Depending upon the situation, it will behave differently. That is, if the data type is integer, then this function will be called. If the data type is long, then this function will be called, like this. These are all stream class. The protected, in the protected variables, private variables are there, istream, g count. Okay, all these are istream operator. So for these functions, okay, if you take over here, all these declarations I written inside only. Okay, declarations I written inside, and I'm writing this definition outside. That's why I'm using this inline. It is an inline function only, and istream. So istream and this operator, I am writing that definition. Okay, it is taking that data from the keyboard. Okay, so all these are istream. So it is taking the data from the keyboard, bp. Okay, that is about istream get function. All the function definition it has written. And the next one is ostream class. This is the ostream class that is there in the iostream.h. So virtual public iOS, same thing. So istream class and ostream class are the subclasses of this iOS class, and that too using multipath inheritance. That's why we are making the common base class as virtual. Otherwise there is a problem called diamond problem. Okay, I will discuss all those things. So all these are the different functions of ostream class. Okay, so that is flash function is there, seek p, seek next lp, put function is there, write function is there, operator, all the operator functions are overloaded. Okay, everything. These are all the functions that are there in the istream class. And we have one more class called iostream class, which is having multipath inheritance, because it is deriving from both istream and ostream class. Okay, so this is about iostream class. And we have istream with assign. This is also a subclass of istream with assign is the subclass of iostream class. Okay, iostream class. Okay, all these are there in the iostream.h. That's why I'm using hash include iostream.h, because cout and cin are the objects of which class? This istream class and ostream class. So whenever I press F7, so it is taking cout is called. Whenever I call this cin, this is very important. Cin age is of what type? Integer type. So it will indirectly call this cin operator greater than. Whenever I execute this thing, then it will internally call cin dot operator greater than integer type. Okay, so I will show you this one. Whenever F7, enter your age 12. Okay, so cout. Okay, so whenever I call this F7, this is cout. I think I will mention one more data type. Cin age comma b. I will take float type, float b. Now again I will execute. So this is output operator. Okay, wherever I call cin age, I have to enter keyboard. So cin, whenever you call this cin function, internally what it will happen is it will call that cin dot operator greater than function that is there in the hash include iostream.h. Okay, so cin. This cout is calling like the same thing. Cin will also be called. Okay, so cin, whenever you call this one, cin dot operator greater than. Okay, so integer function will be called, that is there in the iostream.h. That's it. So next, standard output stream. Okay, so usually the standard output device is the display screen, that is monitor. Okay, we are displaying, right? So whatever, where is the output is showing, this one, this is your monitor. Okay, so usually the standard output is the display screen or console. Okay, so cout is an instance of OStream class. Just now we have seen that also. After entering float value, that is 3.5. okay, so whenever I press F7, it will go to this OStream. Okay, this is the OStream class. Inside this OStream class we have this operator less than, and this is of integer type. So your age is, I am writing, right? So that's a constant signed characters there. So it will call that thing, and after that it will go to the integer function. Okay, because we are using this age also, right? Age means that is integer, so it is calling both, and it will display that value, and after that get ch, so it will display output. That's it. Okay, so here what is the final conclusion that how to take, usually the standard output device is monitor. Cout is an instance of this OStream class. So cout is used to produce output on the standard output device, which is usually display screen, that may be console also. Okay, the data needed to be displayed on the screen is inserted in the standard output stream using the insertion operator. So if I are taking this one cin, I will take the data from the keyboard, and it will be incremented, and after that I am displaying the data. Okay, so here I have to take the value, right? So I will enter this 23, so that 24 will be displayed. Okay, as you can see in the above program, the insertion operator is used to insert the value of the integer variable in the standard output stream, which is then displayed on the screen. Okay, so this is about, so the final thing is we have a class, iOS class is there. iOS is the base class for all these are there in the header file, that is iostream.h header file. Okay, inside this .h header file we have a class called iOS class. For this iOS class we have a iStream. Stream is the subclass of iOS, and one more class is there, that is OStream. OStream is the output stream, which is a subclass of this iOS class, and from this iStream and OStream class we have a derived class called iOStream. And from this iOStream also we have iOStream with assign. Okay, this is the hierarchy. Okay, this we will discuss. This is the hierarchy of classes, that is iOS is the base class, but it is of multipath inheritance. That's why I will make it as common base class as virtual. I'll discuss why I am making it as common virtual. But iStream class is there and OStream class is there. Inside this iStream class, okay, this is a class iStream class, and the object for this iStream class is cin, which is used to take the data from the standard input device keyboard, and also it has a extraction operator called this one, less than. And OStream class we have a object called cout, okay, which is the standard which is used to display the data onto the standard output device, that is monitor. Okay, and this OStream class has an insertion operator, that is less than. Okay, this is about standard input output stream. And the next one is unbuffered standard stream, that is C error. Okay, C error is a standard error stream, which is a error stream. Okay, which is used to output the errors. C error is like cin and cout. We have C error, which is a standard error stream, which is used to display the outputs on the display the errors on the standard output device. This is also an instance of this OStream class only. This is also an instance of OStream class only. It is unbuffered, so it is used when we need to display the error message immediately. It will display the error message immediately under the monitor. It won't store that error in any log file. That's why this is called unbuffered. It is not stored in anything anywhere. Okay, it does not have any buffer to store the error message and display later. Okay, so that's the difference between C error and next one, C log. Okay, in case of C, all these are the input output operators. Okay, in case of standard error stream, that is C error. Okay, all these only C, except Cin. Cin is an instance of iStream class, but what are the object of OStream classes are Cout, C error, and C log. And what is the difference between C error and C log is C error is unbuffered. So when the error comes, then it will display the error immediately onto the monitor. It won't store these errors in anywhere, so that I can see those errors later. That is standard error stream. Okay, so that is your standard error stream. So we will see one example. So if I take this one, so see error and error occurred. So I will take get ch. The screen C error. So it is OStream operator. This one only calling. Okay, OStream operator. So an error occurred. That's it. Okay. So it is just displaying that an error occurred. So whenever that error is there, it is like normal output operator only, output OStream only. But the only thing is, it will display the error immediately. It won't store this error in anywhere. Okay. That is unbuffered standard error stream. Next, buffered standard error stream. So this is C log files. Whenever you go for this RDBMS subject, okay, if you take that one, whenever you create the database, whatever the transactions that are performed on that particular thing, transactions means nothing but input output operations like insert operation, delete operation, DML operations, everything that will be recorded on a log file. So this is also an instance of OStream class only. So for this OStream class, we have three objects, that is C out and C error and C log, which are used to display errors. But unlike C error, and the error is first inserted into the buffer and is stored in the buffer until it is not fully filled. Okay, the error message will be displayed on the screen too. Both will be done parallelly. Okay, if you take C log, if you want to see the help, just click on help and index. Yeah, C log. Okay. So C++ provide these predefined stream objects. Okay, these four are the stream. What are these ones? Okay, these are the objects. Okay, predefined stream objects. We have the stream class. Okay, iostream.h header file. In the iostream.h, we have three important stream classes. Okay, that is iOS is the superclass, and iStream, OStream, and iostream. Okay, and fstream also there. That is about files. So in case of iStream, this is Cin is an object of iStream class, that is standard input, usually keyboard, corresponding to std in C language. Okay. In case of Cout, this is standard output, usually that console screen or whatever you are seeing monitor, that is monitor screen, corresponding to std out in C language. And this is your C error, which is standard out error, but output usually screen only. This is also screen, but corresponding to std error in C language. Okay. And the last one is C log, a fully buffered version. Buffered version is nothing but the output will be stored, not only displayed on the monitor, but also it will be stored on the buffer. Okay, that is your any buffer. Okay, you can redirect C and C out S error from to the directories. Here is the simplified view of streamable classes. So stream buffer, all these are the classes. iStream class, OStream class, iOStream class. iOS is the super class. Stream buffer class is there. I stream with assign, O stream with assign. Okay. We take this IOS, so this is the hierarchy. Okay. See the hierarchy. This is the IOS is the super class. For this IOS class, equivalent to stream buffer will be there. Okay. Stream buffer. And for this IOS class, iStream is the subclass of this IOS, and OStream also subclass. And we have stream base, str stream base, and fstream base, str stream buffer, file buffer. This is the hierarchy. Okay. We have different header. So this one. Okay. So if you take this CLog, this it is a simple, right? So that's why it is displaying on the monitor. But only thing is an error file. You open that ctc bin. Bin. If you take, this is your standard error. It is not creating, but generally, usually, what is the meaning of this one? That is buffered standard error stream, that is CLog, which is used to create the log file. Okay, log file, that is nothing but a buffer. Okay, an error occurred. So that is about the first topic. Okay, so in the today's class, what I discussed, that is our C++ IO operators and their meaning. So next one is basics of formatted IO. So formatting related. So next topic is basics of formatted. So I will discuss what are the basics of formatted IO. Then after that we will conclude the class and we will continue in tomorrow's. Okay. So basics of formatted IO. In many applications, we need to display the output in specified format. Okay. So the meaning of this formatting. Okay. So how the output should be displayed, how the output should be formatted, that will be discussed in the basics of formatted. So in many applications, we need to display the output in specific format. To facilitate formatting, C++ provides various formatted console input functions, input output functions for formatting the output. They are of these types. So that is IOS class member functions and flags, and standard manipulators and user defined manipulators. Okay, these are the three things. Okay, so by using IOS class can have some member functions and flags by using which we can do this formatting, or we have standard manipulators in the IO manipulator.h header file, that is by using that one also I can do formatting. And we have user defined manipulator also. User defined means the user can manipulate, create his own manipulators. Based on that manipulator, the output can be displayed in specific format. Okay, so these are the different formattings we can do in this one. So IOS grant operations common to both input output operations. These classes are in the IOS, we have iStream class, OStream class, and IOStream class, which are special IO with assign level formatting operators. The IOStream is automatically loaded into the compiler. iStream, which is used to perform formatted input operation. OStream, which is used to do formatting output, and IOStream is used to formatting input output operations, both. Stream buffer, which is also another class, an abstraction for connecting a physical device. Classes derived from it works with files. Whenever we want to connect our program with files and memory, then I will go for the stream buffer. The IOS communicates to a stream buffer. It keeps information on the state of stream buffer and saves flags for use by the iStream and OStream. Okay, so everything about this iStream. So in the next class we will discuss what are the different formatting specifiers. Formatting can be, how this formatting of input output can be done by using these three, iOS class member function, standard manipulators, and user defined manipulators. So in today's class, we discussed about the C++ basic IO operators. What are those basic IO operators? That is cin and cout, cerr, and clog. Okay. So cin is an object of iStream class, which is used to do standard input operation, that is taking the data from the keyboard, and which is also having one operator called extraction operator. By using that extraction operator, I can take the data from the keyboard. And cout is an object of or instance of a class called ostream class, which is used to display the or which is used to do write operation or display the data onto the monitor or console. And it has one operator called insertion operator. Okay. And cerr is nothing but it is a unbuffered, which is also an instance of this ostream class only, which is used to perform unbuffered operation, which is used to display the data onto the display errors onto the monitor. It won't store this errors in any buffer. That is about cerr. But clog is a buffered version. Okay, buffered, which is also instance of this ostream class only, but which will do insertion of the errors into the monitor, as well as at the same time those errors will be stored on a buffer. So with this I am concluding the today's class, and in the tomorrow's class, and we discussed about what is the basics of formatted IO. This can be done by using three things. One is iOS class member functions, and we have the standard manipulators, which are there in the IO manipulator.h header file. And the next one, this is standard manipulators, and the next one is user defined manipulators. So what is the use of this manipulators? Are used to do the formatting of input output. Okay, if I want to take the input in specific format, or if you want to display the output in specific format, then that can be done by using formatting input output. That formatting input output can be done by using these three iOS class member functions. We have different member functions. We will discuss all these member functions in the tomorrow's class. Same thing, by using this IO manipulator.h, we have some member functions inside. We have some functions, not member functions. Some functions are there in this header file. By using those also we can do these manipulations, and I can create my own manipulator also. Okay, these are the three manipulators by using which I can do this formatting IO. So that's it. That's all for today's class. So tomorrow we will discuss this basics of formatted IO in depth. Okay, thank you all.